Samsung is reportedly developing an AI-enhanced modem chip designed to work with SpaceX's Starlink satellite network. This is not a consumer AI chatbot partnership. It is a hardware-level satellite communication development, a modem that uses embedded AI to optimize connectivity with fast-moving satellites. In this video, we'll break down what Samsung is actually building, what Starlink gains from this collaboration, how AI fits into satellite communications at the modem level, and whether this signals the beginning of 6G satellite native devices. Let's start with what is established fact versus what is reported. Samsung's System LSI division, the team responsible for designing semiconductor chips, is reportedly working on a new Exynos modem. Multiple industry sources and telecom publications have covered this development. The modem integrates AI acceleration through an embedded NPU, neural processing unit. The stated purpose is to optimize communication with low Earth orbit satellites, specifically Starlink's constellation. This is critical to understand. The AI integration here is about modem-level optimization. It's not about adding chatbot features to phones. It's not about generative AI. It's about using machine learning algorithms embedded in the modem chip itself to make satellite communication more efficient and reliable. To understand why this matters, we need context on Starlink. Starlink operates a constellation of approximately 7,500 LEO, low Earth orbit, satellites. Unlike geostationary satellites that stay fixed above one location, LEO satellites move rapidly across the sky. A satellite passes over a given location on Earth every 12 to 24 hours, depending on its orbital altitude and inclination. That means a smartphone using Starlink for internet must continuously hand off its connection from one satellite to the next as the satellites move overhead. Traditional cellular modems are designed for terrestrial towers, which are stationary. Maintaining handoff to a new tower is predictable. Maintaining handoff to a rapidly moving satellite is a different problem entirely. This is where the technical value becomes clear. Traditional terrestrial modems don't need to predict much. A cell tower is in a fixed location. A modem knows where it is and roughly where nearby towers are. Signal handoff happens on a regular schedule. The modem can follow a pre-programmed routine. LEO satellite modems face a fundamentally different challenge. First, they must track satellites moving at roughly 17,500 miles per hour relative to Earth. The modem needs to know not just where a satellite is now, but where it will be in the next few seconds, so it can predict when to hand off the connection. Second, they must manage Doppler shift, the change in signal frequency that occurs when the satellite is approaching or receding. As a satellite moves toward you, the signal frequency increases. As it moves away, frequency decreases. The modem must continuously compensate for this shift or the signal degrades. Third, they must predict beam switching. Starlink satellites have multiple beams that can point in different directions. The modem must predict which beam will serve its location and optimize for that beam before handoff occurs. Fourth, they must handle frequent handovers. Instead of handing off once every few minutes like a terrestrial phone, a satellite modem might hand off multiple times per minute. Each handover is a moment of potential connection loss. This is where AI provides value. Machine learning algorithms can learn patterns from historical satellite tracking data and predict future trajectories with high accuracy. AI can optimize signal timing, knowing exactly when to adjust power levels, antenna tuning, and beam selection to maximize signal strength during handoff. AI can reduce latency spikes that occur during handovers by preparing the connection path milliseconds in advance. AI can improve power efficiency by learning which modem settings use less power while maintaining signal quality, critical for battery life. AI can manage dynamic bandwidth allocation by predicting when bandwidth will be congested and adjusting transmission strategies accordingly. The key point, this is embedded signal optimization, not generative AI. The algorithms are deterministic, trained on satellite orbit data and signal patterns. They run continuously on the modem chip itself, making millisecond-level decisions about signal management. This is different from an AI chatbot or a language model. This is optimization at the physical communication layer. Starlink has already launched Direct-to-Cell D2C initiatives, which allow standard smartphones without special satellite hardware to connect to Starlink satellites directly. Currently, D2C is limited to text, messages, and emergency location services. The service is available in select regions and requires no changes to existing phones. It works by having the phone transmit data at higher power than normal to reach a satellite. Samsung's AI-enhanced modem could expand what Direct-to-Cell is capable of. An optimized modem could improve satellite handshake stability, the critical moment when a phone first connects to a satellite or switches from one satellite to another. Reduced dropped connections means users experience fewer call drops or message failures. Enhanced energy efficiency in satellite mode means phones drain their batteries less quickly while using satellite connectivity. Faster handoff could reduce the delay users experience when moving between satellite coverage zones. However, we need to be clear, no official Samsung phone has been announced with Starlink integration yet. There is no confirmed roadmap. This is a development effort reported by industry sources, not a consumer product announcement. Let's be precise about what is and isn't confirmed. There is no formal press release from Samsung, SpaceX, or Starlink announcing a global partnership specifically for this modem. Reports about Samsung's satellite modem development come from industry sources, telecom publications, supply chain analysts, and insider sources. Multiple credible outlets have covered this development, suggesting there is real activity behind the reports. However, the information is not officially confirmed by Samsung or Starlink through public statements. No launch date has been confirmed, no product roadmap has been published, no specifications have been released, no pricing information exists. This is reported development work, not an announced product. This distinction matters for credibility. When a company officially announces a partnership, they hold press conferences, release detailed specifications, and commit to timelines. When development work is reported through industry sources, it means something is happening, but it's not yet ready for public announcement. There could be technical delays, there could be regulatory approval issues, there could be changes in strategy, the modem could launch, or the project could pivot or be canceled. Given what is publicly known, we should treat this as Samsung is reportedly developing an AI-enhanced modem optimized for satellite connectivity. The effort appears aligned with Starlink's Direct-to-Cell expansion. Neither company has officially confirmed this partnership. Now let's expand this from a single modem development to the larger infrastructure picture. The future 6G vision, which is still in research and standardization phases, includes non-terrestrial networks, or NTN. This means networks that are not limited to terrestrial cell towers. Instead, devices would seamlessly switch between ground-based cellular infrastructure and satellite infrastructure, getting the best signal from whatever source is available. In rural areas with poor tower coverage, phones would use satellites. In cities with dense tower coverage, phones would use towers. In flight or at sea, phones would use satellites. The network would be truly global, with no dead zones. Samsung is heavily involved in 6G standardization and research. The company is part of industry alliances working on 6G specifications and is publishing research papers on satellite integration. Starlink is already building the global satellite infrastructure that would support such a network. An AI-enhanced modem that optimizes satellite connectivity directly supports that long-term vision. This is not Samsung and Starlink inventing 6G. It's infrastructure companies preparing for the 6G architecture that industry groups are designing. Samsung is ensuring its chips can handle satellite connectivity at the modem level. Starlink is ensuring its network can provide reliable service to consumer devices. From a competitive standpoint, other major chip makers are moving in the same direction. Qualcomm has been developing satellite modem technology. Apple launched emergency SOS via satellite using Globalstar's network, which required custom modem and antenna integration. Huawei is developing satellite messaging in China. MediaTek is exploring satellite connectivity for mid-range chips. This is not an experimental side project for any of these companies. Every major chipmaker is preparing for satellite-native connectivity. Samsung joining this race is strategic, not experimental. Before we assume this modem will be widely deployed, we need to acknowledge significant engineering constraints. Power consumption in satellite mode is a major challenge. Transmitting to a satellite requires higher power than transmitting to a nearby cell tower. Higher power means faster battery drain. The AI optimization can improve efficiency, but physics still sets limits. A phone using satellite connectivity will have worse battery life than the same phone using cellular towers, regardless of how well the modem is optimized. Users will need to accept this trade-off. Antenna limitations in smartphones are another constraint. The best satellite antennas are directional. They point at the satellite to maximize signal strength. Smartphones have antennas that work omnidirectionally, pointing in all directions. You can't add a large directional satellite antenna to a smartphone without making the device impractically large. This limits the signal strength a smartphone can achieve with satellites compared to a dedicated satellite terminal. Bandwidth constraints in LEO networks are significant. Starlink's constellation can only carry so much total data. During peak usage periods, available bandwidth per user is lower than terrestrial networks. D2C messaging works well because messaging uses little bandwidth. High-speed data or video streaming would quickly saturate the network during peak hours. The modem can't fix this. It's a network capacity issue, not a modem issue. Thermal management is critical. The NPU in the modem will generate heat during intensive signal optimization. The phone's thermal design must be able to dissipate that heat without throttling the modem's performance or overheating the device. Regulatory spectrum approval is required in every country. Starlink operates under specific frequency allocations approved by national regulators. Some countries are more permissive, others are more restrictive. A phone that can use Starlink in the United States might not be legal to use in another country due to different spectrum regulations. This slows global rollout. The broader point, AI can optimize signal, but physics still limits performance. A modem can be perfectly designed and still be constrained by power, antenna size, network capacity, and thermal dissipation. This is why satellite connectivity will likely remain supplementary to terrestrial networks for consumer phones, not a complete replacement. Let's clarify what some people might mistakenly assume. This is not Starlink launching an AI chatbot or adding generative AI features to the network. The AI is embedded in the modem for signal optimization, not for content generation or autonomous decision-making at the network level. This is not Samsung building satellites or taking on Starlink's role as a satellite operator. Samsung is a chip designer and manufacturer. Starlink is the satellite network operator. They have different roles. Samsung makes the modem, Starlink provides the network. This does not mean all Samsung phones will have satellite internet next year. Even if the modem is successfully developed, regulatory approval, antenna integration, and manufacturing scale-up take time. These things are measured in years, not quarters. This does not eliminate telecom carriers. Terrestrial networks, 5G, and eventually 6G will remain the primary infrastructure for mobile connectivity. Satellite networks will be supplementary for areas without tower coverage or for emergency services. The two systems will coexist, not replace each other. Keeping these distinctions clear preserves credibility. We're talking about a specific modem development that aligns with a long-term infrastructure trend. We're not talking about a revolutionary new satellite internet service launching immediately. Let's bring this together. Samsung is reportedly developing an AI-enhanced modem optimized for satellite communication with Starlink. The modem uses embedded machine learning for signal optimization, trajectory prediction, Doppler shift compensation, beam switching, and power efficiency. This development aligns with Starlink's direct-to-cell expansion and with the industry-wide preparation for 6G non-terrestrial networks. Formal product announcements from Samsung or Starlink are still pending. No launch date or specifications have been confirmed. The real impact of this development is long-term, not immediate. It signals that infrastructure-level evolution toward global, hybrid satellite terrestrial connectivity is accelerating. Within the next 5 to 10 years, devices may seamlessly switch between cellular towers and satellites without user intervention. Emergency services will have more reliable connectivity in remote areas. Aircraft and maritime applications will have more options for data connectivity. The network will be more resilient to local outages. This is infrastructure investment, not consumer AI. But it matters. AI is not just changing software anymore. It's optimizing the physical layer of communication networks, the modem, the signal processing, the antenna integration. Every layer of technology is being enhanced with algorithmic optimization.